It's likely that we humans have been fascinated by our voices since a Neanderthal produced his first grunt. We wonder, how can a great opera singer's voice fill an entire music hall, or how does an impersonator perfectly mimic the voice of the president? Understanding how humans produce song and speech has been a tough task for scientists. The main generators of voice lie deep in the body, where they are hard to see. It is only with the help of a medical instrument that we can take our fantastic voyage. This instrument, called a videostroboscope, has a miniature video camera and light attached to a long rod. With the help of this special tool, we will look at three major components of speech. Let's begin the voyage with a look at the articulators. Did you see the size of that bottom lip? I may not have mentioned that the videostrobe also magnifies. Now we're traveling past the bottom teeth and the tongue. The lips, teeth, tongue, and other structures of the mouth shape sounds into understandable words. Now we're nearing that punching bag-shaped structure in the back of the throat. Sometimes people mistakenly think this is a tonsil, but it's actually the uvula. Let's pause here to consider how the throat and mouth influence the way we sing and speak. With your lips in a rounded position, say, oh. You've essentially created a tube between your voice box and lips. This shaped airspace, called the vocal tract, is not unlike a cave. Sounds bounce around the sides, top, and bottom. Some sounds become stronger as they are bounced around, while other sounds are lost. Here we go again. With a videostrobe light at the back of the throat, now we look downward, toward the feet, to see what else makes up the vocal system. See that flap? It's the epiglottis. Muscles push the epiglottis down to seal off the airway when we swallow liquids or food. This keeps us from choking. Let's glide past the open epiglottis and things are really getting interesting. Now we've reached the second important part of the vocal system, the vocal folds. They are housed in a structure called the larynx. Here you can also get a glimpse of the airway leading down to the lungs. As you can see, we humans have a left and a right vocal fold. Watch while our willing subject simply breathes, not talking or singing. There is little activity of the vocal folds themselves during breathing. This is about to change. Watch now as our subject makes sounds. See the vibrations of the vocal folds? Do you notice, too, that when the muscles of the larynx pull the vocal folds into long, thin shapes, the sound he makes is high in pitch? To make a low pitch, the vocal folds must be made short and thick. Isn't it amazing how our brains coordinate these activities without us consciously thinking about them? Wait, now he's changing pitch all in one breath. See how the shape of the vocal folds changes as he goes from the low notes to the high and back down again? The strobe light of the instrument allows us to see vibration. In reality, the vocal folds come together about 200 times per second. Note the different complicated movements of the vocal folds. In addition to moving together, the vocal folds also move from bottom to top during voicing. Because the vocal folds are also squishy, they change shape when they are pressed against one another. Scientists have tried to duplicate all of these movements with computers, and they are finding it a difficult task. This patient's vocal folds look healthy, although there is a little redness, and he says he's been singing a lot. Notice that the inside edges of the vocal folds are nice and straight. Sometimes, if people talk or yell too much, nodules develop. If this person had laryngitis, the vocal folds would look puffy and red. Finally, we note that the vocal folds are moving well together. If the vocal folds differed greatly from one another in shape or movement, the voice would sound rough or raspy. This is as far as the videostrobe can illuminate, but do you know where we'd be if we could keep going? We'd go into the breathing tube called the trachea and down into the lungs. The lungs provide the final essential part of the vocal system, air. Air is the fuel used to power the voice. Air whooshing past the vocal folds causes the movements we just saw. We breathe in air, and after our lungs have taken oxygen out, we exhale. Since this human's vocal system seems to be working well, I'd say our mission is accomplished. Let's blow out of here.